In this example, we're asked to graph a linear inequality 2x plus 3y is greater than 12. Now, anytime we're asked to graph a linear inequality, we're going to do two things. We're going to, first of all, instead of an inequality, we're going to graph the line. Uh, 2x plus 3y equals 12. So that's the first thing we're going to do. And then the second thing we're going to do is we're going to test the initial inequality, the original inequality, with a point not on the line. And finally, as part of that, we're going to shade one side of the line. So we'll end up with a line that cuts through our graph or our axis, and we're going to shade one side of the line. Whichever side we shade depends on this test that we do in step 2. Okay, so let's do the first step, graphing the line. Okay, so we have to graph the line 2x plus 3y equals 12. Now, you've already been taught two ways to graph a line. And probably the easiest way for you in most cases was to write the line in slope-intercept form. In other words, with y on its own. So let's do that. If we were to write this line, 2x plus 3y equals 12, with y on its own, 2x is on the wrong side. So we've got to move the 2x over. And if we do, that will leave you with 3y equals 12 minus 2x. And if we want to get a single y on its own, we have to divide everything by 3. If we divide 3y by 3, we'll just have y. If we divide 12 by 3, we get 4. And if we divide negative 2x by 3, we get negative 2 over 3x. 2 can't be divided by 3, so we just leave it as 2 over 3. Now, once we have it in that form, with y on its own, the bit that's in front of x, this bit here that's in front of x, that's going to give us the slope of our line. Okay, so the slope is negative 2/3. So how do you know that? You know it because y is on its own on one side of the equation, and negative 2/3 is the number attached to x in front of x. So that means that's the slope of the line. The other piece that's here, this piece here, the 4, that's going to be the y-intercept. Okay, so the y-intercept is 4. So now what we're going to do, we're going to first plot the y-intercept, which is, if you want to write it strictly as a point, it's going to be 0, 4. So it's going to be 4 on the y-axis. And then 2, the slope. We've just said the slope is negative 2/3. Now remember, the slope is the rise over the run. So what we're going to do is begin at the y-intercept. The rise is negative 2, so because it's negative, we're going to come down 2 units. And then move across 3 units. And then once we've got that, that'll give us a new point. Okay, that'll give us a new point. And once we've got the first point, 0, 4, and the new point, we can draw the line through them. So that's what I've done here. And I'll just paste it here. And you can see 0, 4, that's the y-intercept. And then I came down 2 units, 1, 2, and I went right 3 units, 1, 2, 3. So this is the second point here. So these are the 2 points, and I drew the line through them. Okay, so there's our line, and that was the first thing we have to do. Now, we could also have done that with intercepts. So let's just take a look at how we would do that with intercepts. Okay, so if we were to do this with intercepts, and you don't have to do it both ways, but you do need to know both ways, because sometimes, especially if you have big numbers, doing it by intercepts is easy. Okay, so the same step, but this time doing it by intercepts. So if it doesn't work one way, it will work the other way. Okay, so it was 2x plus 3y equals 12. Okay, so what we'll do is we'll let x be 0. Now if we put x equal to 0 into this equation here, that gives you 2 times 0 plus 3y equals 12. 2 times 0 is 0, so 3y equals 12, so y is 4. So that's going to give us this y-intercept here, 0, 4. Okay? Okay, so that gives us 1 point, and if we want to get the other point, we can let y be equal to 0. Okay, so we go back here, and then 2x plus 3 times y, but now the y is 0, equals 12. So it's going to be 2x, 3 times 0 is nothing, so it's just 2x equals 12. So x will be 6. So that gives you the point. The x is 6, and the y was 0. So that gives us the point 6, 0. And you can see that that point was on the curve as well. That point was on the line as well. So we could have done it either through the first way, by writing the equation of the line in slope-intercept form, figuring out the y-intercept and the slope, or by doing it by intercepts. And either way, we still get the same line. Okay? Now that was the first step in all of this. The second step comes next. And the second step, what we do in the second step, if you look back here, the second step is to test the original inequality with a point that was not on the line. Now the point that we nearly always use is 0, 0. And if we just check 0, 0, the point 0, 0 certainly isn't on that line. 0, 0 is down here. Okay, it's definitely not on that line. So the original inequality, if we go back to the question, was 2x plus 3y is greater than 12. So this is step 2. Test the original inequality . 2x plus 3y was greater than, okay, it was greater than 12. Okay, so we go back there. 2x plus 3y is greater than 12. Okay, with 0, 0. Now it has to be a point that isn't on the line, and the point we normally use is 0, 0. If it is on the line, then use either 1, 0 or 0, 1. But anyway, it wasn't on the line in this case, so we're just going to put in 2 times 0 plus 3 times 0 is greater than 12. 2 times 0 is nothing, 3 times 0 is nothing, so that's 0 is greater than 12. Now that's obviously false. Okay, that's obviously false. So what we do then is we shade the side of the line that does not contain our test point. Our test point was 0, 0. We shade the side of the line that does not contain the test point. Which was 0, 0. Okay, so let's pull back that, let's bring that graph back in here. Okay, so this is our original graph. Okay, here's the line. So we're either going to shade, if I can pick out the right color, we're either going to shade above the line like this. Okay, so we can shade one side of the line, that's shading above the line, or we could shade below the line. Okay, so we get to decide whether to shade above the line or below the line. We want to shade the side of the line that does not contain 0, 0. Okay, well, here's 0, 0 down here. 0, 0 is the origin. Okay, so we can see that it's on the bottom side of the line. We want to shade the other side of the line. So let's get rid of the shading here. Okay, we're going to get rid of this shading here. Okay, and 0, 0. We want to shade the other side of the line. Okay. Now the other problem that we have here is that the inequality was just greater than, not greater than or equal to. So if it's greater than, that means we need to use a broken line. Okay? So we're not completely finished yet. So we're going to import now the final answer that has this line, this dividing line, broken. And that line now looks like this. Okay, so we've got our broken line, and we've got the area shaded, the area that does not contain 0, 0. Okay, so it looks nice and neat when you do it on the calculator or on the graphing calculator. It doesn't look neat otherwise, and it takes quite a long time to do these problems. You break it up into 2 steps. The first step was just graphing the line, and then the second step is to do your test and then decide which side of the line you want to shade. The other thing you have to remember is that if you're using a greater than or less than, you use a broken line. If you're using greater than or equal to, less than or equal to, you'd use a solid line. Okay, so I know this is a long one, and each example is going to take you quite some time. But if you break them up into 2 steps, you'll find that it's a little bit easier to handle. As you do these problems, go back and review this video, pausing it as often as you need until you're confident that you're managing to do the problems correctly. Okay, thanks.